let's see. Oops, now I am. I think Twitch saves it too. They're up and away. Okay, so I have the Windows calculator. Uh, Everyone thinks, wow, the Windows calculator is such a piece of shit, but it's actually pretty cool. If you click the hamburger menu up here at the top left of the calculator and pick programmer, you get like a different looking calculator here. And what's going on, what I want to do is figure out like, why are these numbers so high? Like you can see, you can't see it right now. But on that graph that showed, here, let's cover me up. We don't need to see me right now. There we go. All right, so we got our graph. Way down here, we're seeing numbers like 3882 or whatever. These are really high, big numbers. If I go to the hex view here, I've got F35. So 0F35 or just F35. You usually see this written like 0x F35. So if I click on hex and then I click F35, uh, Windows, shitty Windows calculator actually gives you some helpful information. So right here in decimal, that's the decimal equivalent of hexadecimal F35. So now you know kind of like where these huge numbers are coming from. These huge numbers generally are refactored either by the car or by OpenPilot or by us. And Cabana in the DBCs is where we do that. So why this huge dip in the graph is significant is because I can see the steering wheel is turned at approximately 90 degrees. And then while he was turning it, I'm just going to skip back. So while he turns and pauses, turns it a bit more. There's a dip, and then the wheel comes back a tiny little bit. And then he turns it more, waits, turns more. So anyways, I'm pretty confident that this is a steering angle reported by the power steering module. So I'm pretty confident in that. What do I do with that information? So in the 2 bytes I've selected, I'm going to expand the pink one, new signal, and I'm going to call the name steering angle. Maybe I'll throw an EPS on the end because the steering column probably also reports the angle. Let's see what it's called in Chrysler land. So it's just called steering and steer angle. This is a bit ambiguous, but just because, let's get rid of the calculator. I'm just going to stick with what's already written for Chrysler, because then we can just hopefully like plug all this stuff in and it'll work. So instead of what I have it called, which is EPS module, I'm going to edit it again, and I'm just going to call it steering. And then in Chrysler, steer angle. Okay, I can remember that. Great. Okay, so we have our name. So we have the message name done, and then we have a couple of 2 bytes. We've assigned steer angle. My plot's buggering up here. There we go. It's back. Sorry, you probably can't really tell what I'm doing there, but I'm just clicking around a lot. So like I said, cabana, I love it, but it's a delicate flower. So we've got our message, our steer angle. Let's take a look at these giant numbers. Not super helpful. But I know that this could be 0. It's really close. Maybe it's turned to the left slightly, but Yeah. Down here, I know it's 90. Up here, approximately, I know it's 0. So I've got 4108 here. And then when the wheels turn 90 degrees, I've got, what, 3880 something. So the first thing I'm going to do is like get this down to something that makes sense. Um, if I pretend that this is 0 degrees, it's pretty tough to know what 0 actually is. But I'm going to say at this flat line where the truck was parked, that the steering wheel was sitting at 0 degrees. So I need to apply an offset. So I'm going to open up the steer angle, and there's information about my selection. The Endianess is talking about earlier. Chrysler is big. I'd way rather do big because little means everything is backwards. It's a total pain in the balls. Some cars needed signed things here, which means only positive values, I think, or you have to specify. Anyways, it doesn't matter. What I want to tackle right now is the offset. So right now I'm at, say, when it was at 0 degrees, it's at 4107. So the offset, if I put in negative 4107, and I'm typing those really slowly because if I type too fast, the graph doesn't update, and then I don't know if I've done it right. But I'm sort of digging it. Now it's at 0 and going up and down when the wheel is turned. So I know that the wheel physically is at about 90 degrees right here. So what value do I have? I have negative 221, which is also just means a right turn. 221 is too high. How much too high is it? It's about half. So I want to see a 90 here. I want to see minus 90. So what we can play with now is the factor. So right now it's a factor of 1. I started with like 0.2 to see what would happen. So minus 3329 and yeah, what do we got? What's the difference here? Somebody who's good at math. It's about 40. Not enough. So I'm going to delete it. I think I settled on 0.4 for this. What are we at? 2476, 2554. That's pretty close. It's really close anyways. So when I change the factor, what happens is the offset changes again. I like looking for offsets that are like a base 10 number. So a base 10 number is basically how binary code is turned into like numbers and letters and all that shit. Base 10 is the numbering system that it follows. And the numbers that we can have are 1, 2, 4, 8, 16, 32, 64, 128, 256, and so on. Do those numbers sound familiar? Probably. It's how we buy storage, or it's how our computer's RAM is measured, or it's how a thumb drive is measured. Like everything except for hard drives, which is bullshit. But everything is generally a base 10 number. So maybe your computer has 16 gigs of RAM or 32 or 64 or whatever. I think generally most automotive manufacturers are going to try and stick with stuff like that that's easy because it reduces processing uh, like reduces processing power and reduces processing requirements. Um, so let's see here, 2464.2. I don't know. That's kind of a weird number, but we'll go with it. So I'm going to say minus in offset. I'm changing the offset again. 2464. Oops. I screwed something up. What is this, 1600 now? Oh yeah, I remember this. So what I'm doing right now is I'm just massaging the offset until I get this point, this flat point right here that I'm pretending is 0. I'm just trying to get that 0. -5. I'm too far. Hmm. Okay. So with a factor of 0.4 and an offset of 1643, I'm just guessing these. Um, but I do have some known information, right? I can see the steering wheel is turned at 90 degrees. I know that just before it was turned, it was at about 0. So right now I've got numbers floating around 0 when the wheel's flat. And then when it's all the way down here, it's at about 90. And I can see that with my factor of 0.4 and this really wacko offset, um, I'm almost there. And you know what? For me, right now, for like development, it's close enough. We don't need to get any closer than this right now. Um, there are ways of getting this exact, but for right now, we've totally found the steering angle. Uh, the unit, this is optional information. I can put degrees. I can make a comment that, let's see, uh, negative negative values indicate right turn, positive positive values indicate left turn. Uh, you can see this comment in Cabana. You can also see it in the DBC, and I'll show you the DBC in a minute. This minimum and maximum value is for like us, right? It's for the developers. It's for the engineers. It doesn't. If you can just leave it 0 and 1, and everything will still work. Um, I know that the highest value this can be is FFFF, so 4 Fs. If you want to know what that is, bring up your old Windows calculator that you've reconfigured as a programmer, because you're a fucking programmer now. And I'll put FFFF into the hex area, and then I can see in the decimal selection that it's 65535. I guess that's another base 10 number somehow. Oh, yeah, because 0 is included. So anyways, the maximum value that the steer angle could get to is 65535. Not super important, but it can be helpful if you are working on a team and taking apart one of these or reverse engineering the CAN data. So that's, what is this? Got a big black thing in the way. Back. Okay, so that's steer angle. Um, and I'm pretty happy with that. So there was some more bytes doing stuff in here, and that was the second 2 bytes of 8. If I'm going to get rid of the steering angle plot for now, and I'm just going to show this one on its own. So these 2 bytes look like this. It kind of looks like a heartbeat sort of thing. So I'm going to, oh, this is super great. Okay, so this is that part where the truck was stopped. I guess it was like stop and go, adaptive cruise control, stop and go, and the engine shuts off, and it's the whole shebang. Anyways, what's great here is this flat spot where there's nothing going on is resting at 4096. That's a base 10 number. Um, I love seeing that shit because if I go into it and I put the offset in at negative 4096 uh, with a factor of 1, I get a 0. Perfect 0. Um, and because I've done this before, I know that this is what torque looks like from steering module. So what we're actually looking at here, after I've put in the negative 4096 offset, I'm just leaving it at a factor of 1 for now. What we're actually looking at, this is torque um, that the EPS motor is applying to the steering gear. Um, it's fairly linear so that we don't feel it in the steering wheel, and it's very smart. The Yeah, it's really cool. So, anyways, without knowing it, when Up and Away was driving around, sometimes the EPS motor is not doing anything. Right when you're cruising down the highway, most new vehicles shut down EPS torque to save power, right? Because if we're not using power, we're not generating, the alternator doesn't have to do any work. And so everybody wants good fuel economy nowadays. So yeah, it's natural to see the EPS motor doing no work when you're cruising down the highway. Um, the torque values kind of look familiar, like they're uh, like I see similar values in other makes. So I'm going to leave this the way it is as far as values go. Um, so the factor of 1 looks good. The offset at minus 4096 looks fantastic. Like I really like that because it gives us a perfect 0 when nothing is happening. So like that's how it works. Like, this is exactly what it looks like. So when the values go up, we know that from steering angle, positive values indicate left turns. So when the peak is going away from 0 up, uh, the EPS is applying torque to the left, and when it's going down, it's going right. So I'm going to call this new signal, well, I want to call it like EPS torque output, but I don't get to do that because Chrysler stuff's already been done. And it's going to be in here somewhere. So we've got EPS status torque driver, and then we have EPS status torque motor. This particular one, this is torque motor. I know that just from looking at it. I can't explain why. It's from Blood, Sweat, and Tears doing OpenPilot. So to save work, I'm just going to call it torque motor. And I'm going to leave it the way it is for now. I'm going to put in the 65535 because I can have 4 Fs. And I'm going to leave it at that for now. Yeah. So what's cool is with these graphs, there's kind of a neat thing you can do where you can, if you hover over the hamburger menu of one of the graphs, you get like the move crosshairs, and you can left click and drag it on top of the other one. And now I have the graphs being overlaid, which is pretty neat. So if I go, I think here, this stretch here, yeah, so Up and Away is just letting the truck kind of bounce off the lines in this section of data. So when I look at the overlaid graphs, I can actually see a correlation between what I think is the steering angle and what I think is torque coming from the EPS. It's bang fucking on. I mean, this is what it is. I don't know that for sure, but I'm feeling pretty good about this. This looks fantastic. So we've got steering angle, torque coming from the EPS, the counter. We saw that cool up down kind of graph, and then the checksum. And that's going to be it for this can ID. I don't think anything else happens. I'm going to cheat again. Oh, you know what I haven't done in a while? Saved this DBC. I'm just creating new ones every time because, I mean, that's what I do. And then at the end, I'll go and put them all together. Sometimes I'll be just going after one thing, like engine RPM, or because I like to do cool UIs and I like to have engine RPM and boost and all that kind of crap. Oh yeah, we got wheel speeds too. I forgot about that. Okay. So I was messing with this last night, had a little bit of time, and I found the steering commands. There's a 166 here. So when you're looking at the DBCs, this is like a raw DBC. This is kind of what they look like. Usually there's tons more of these sections that'll say like EPS and steering and brakes and wheel speeds and all that shit. So last night I figured out that can ID decimal 166. So I'm gonna punch into my Windows calculator thing. Decimal 166 is hex A6. So I'm gonna scroll down the list looking for A6, alpha 6. Okay, here it is right here. No, I'm not going to say I got lucky because I didn't. I was watching the video and I know that typically lane keep commands aren't sent as often as critical systems. In this case, it looks to be about half. So 50 hertz. Remember that number because you know what? I'm going to type it in here because I think these messages are saved forever. That's for you, up and away. 50 hertz. Remember that. Oh, I guess we can just look. Duh. Why are we not getting a list? I guess it doesn't matter. Right. So last night, it's kind of late. I'm watching, and I found what I recognized this. Okay, so I'm kind of cheating. If you're brand new to Cabana and you're looking for this stuff, like all I can say is like look for the patterns. Look for numbers that go up when certain things happen and numbers that go down when other things happen. And the lane keep commands were no different in this case. And it's also because I've done ports for other Chryslers. They use this same format. So like, thank God something is like a little bit uniform. So this 400, this 000400, is pretty significant because if we watch it, I got to make sure I'm in the part of the video here where he's letting it bounce off the lines. Okay, here we go. Okay, so I got lucky. Oh, shit. Okay, stop. Oh. Okay, great. Got it. So if you were carefully watching this CAN ID and this CAN data, you'll see that the 000400 that was once there is not there anymore. It's got 37D in place of the 400, which is a negative value. if we're saying that 0400 is 0, now we've got 37D, which is lower than 400, and we know that negative numbers go, I think, right, which makes sense. Yeah, because we've got a yellow lane line here, which means the truck is concerned that it's going to cross over the left lane line, so it wants to turn the wheel right. And we see a negative value here showing up. I was like, oh, that's pretty interesting. So what I did was I selected those 2 bytes. I want to say 2. Yeah, it's 2 bytes. So double click, and now I'm left clicking and dragging to grab my the 2 bytes. These other ones up at the top, they don't do anything. I don't think I ever saw them move. But the ones that do move, I highlighted. I clicked show plot, and I saw a very familiar looking graph of what steering commands from lane keep systems look like. So this is like the bread and butter of OpenPilot. Okay. This is what we're hijacking. Like exactly these signals. OpenPilot's only job with lateral control is to generate this. And then your vehicle handles the rest. Obviously, OpenPilot does a lot more than that. But at the very like basic OpenPilot fundamentals level, this is what it does. It just sends them bigger and longer. So I was really happy to see that. I was also really happy to see 1024 in a nice straight line here. So like if you remember, that's where to get the offset information from. So I've got this graph that's floating at around 1024 units. And I say units because when we have, let me get to the bottom of one of these. Okay. So, or the top. Whatever. Get anywhere, mouse. Okay. So at this peak over here, it's 1220. And then it goes back down to 1024. Like these numbers don't make sense at 1024. So I'm going to put in the offset again. Minus 1024. And then I get everything. So now I got true 0. Yes, sweet. And then I'm looking at these peaks and valleys, and I can see values like minus 240. And then positive 202. Those are familiar values because if I go to Chrysler, oh, by the way, if you go to OpenPilot, self-drive, car, and Chrysler, if you're working on a Chrysler, this is where you'll find all the files that are relevant and that we need to make for your particular vehicle. And if I go to values, I can see this is what maximum steer we can use. So 261 is already implemented for the Pacificas and the Grand Cherokees. So when I'm looking at this new RAM that we've never seen data for before, and I'm seeing values that don't exceed that but come close, I'm thinking I'm on the right track. It's just confirming what I think, right? So this is it. This is the OpenPilot bread and butter. I'm going to go ahead and guess that it's called LKAS command. Yeah, there it is. What's it actually called though? 1 second. Anyway, it's called LKA. Lane keep assist command, whatever. LKAS command. That's the one. I'm going to leave it at a factor of 1 um, because these values look familiar and I don't want it to change. I mean, because if we send values that are too high, the truck will fault and then you got to pull over and restart it. And that's what happens when we ask for too much torque. So basically what'll happen if we, the forward camera, open pilot, if we send a value that's too high, the EPS module down under the hood there will fault. And as soon as that happens, we can't use open pilot anymore, and that's a real drag. And Chryslers are the worst. I don't know if the Ram is more fault tolerant than previous models, but holy cow, the Pacifica owners, they just get beaten to death by LKAS errors. It's no good. So I am going to continue watching. I'm pretty happy with what I've found here. I'm just going to hide this and show it again so that everything updates. There we go. I haven't saved my DVC in a while, so definitely going to do that. Save your work. So I'm a visual effects artist by education, and I learned 3D modeling and effects on Maya. And Maya is like a great program, but if you don't save your shit like every 5 minutes, especially 20 years ago when Maya was like new, 21 years ago, my God. Anyways, save your work. Same with Cabana. Save your stuff. So now I'm back to watching. So I'm pretty confident that new message here. This is, I'm just going to call it forward camera for now. I'm probably going to have to change it if I want to use data that's already been created for Chrysler. If you're porting another car, like I saw a really funny meme the other day that said like I'm a coder or I'm a programmer or something, and then it showed the Control, the C, and the V keys on his keyboard were worn out. Literally, that's like what we want to do here. Copy as much as you can. I think what's 3Fs? 4095. There we go. Unit. I'm gonna leave it. Yeah, I don't even need to explain this. That's what it is. That's the bread and butter. So I'm looking at the CAN data again because we're not quite done. So the truck is cruising right now. I'm gonna just show this. Go back a little bit. So up and away is cruising down the highway. I don't want him cruising down the highway though. I want him somewhere else. So I'm clicking through this timeline right now. And oh, by the way, Cabana shows everything like if this timeline video slider thing and the graph, the big number on the left is the time in seconds from when you started your drive. It's kind of confusing, and I wish it would just show like the date and time somewhere. I can make a feature request. Overlay date and time, yay. So I'm going to skip ahead a bit further. Okay, good. What I'm hoping happened. So I'm still looking at this this CAN ID over here. I'm just going to scroll down a little bit so it's not right above my head. So right now I got a lot of zeros again. And I noticed though back here when the truck was adaptive cruise control was on and he was just cruising, I noticed this 2 right here. And this 2 is significant because what that bit does. So this 2, it's this bit right here. Wow, what a shit color it chose. So it's this one. When the lane keep assist system is ready and enabled, this bit turns on to tell the EPS module, hey, I'm green light for lane keep commands. So basically, if we are going to issue OpenPilot, like if OpenPilot is going to send these torque commands to the EPS module, we also have to send this bit. We have to tell the EPS module ahead of time that we're going to be sending stuff its way and that it needs to steer. So that's this bit. I forget what it's called in here. Actually, the Chrysler one's kind of messy. It hasn't had any cleaning up or anything. Well, it has been cleaned up and refactored and all sorts of stuff. But what things are called is kind of like weird. It's probably this guy right here, maybe. Yep. So lane keep assist state. For this particular cabana, I'm just going to go with. I've only ever seen 0 and 2 for this byte here. And if I watched, the only thing that was changing was this single bit. Sometimes we just need to send like single bits, and this is one of those cases. What do we call it again? Fuck. LKAS state. Yeah, that's like all we kind of need to do for this one. I will make a comment though that this appears to be the LKAS ready indicator. I don't need to put that stuff in my own DVCs if I'm doing my own car, but I'm hoping that this becomes like a group project. And these comments are really helpful. There's no save button or anything, by the way. So as soon as I'm done typing and I've clicked in another field or clicked around elsewhere, or even just collapsed it, it saves. But it only saves to the browser. I still need to go up here and click Save DBC and save it to my GitHub or download it or whatever. Or else if Chrome crashes or Cabana crashes, it's lost forever. Okay, so that's kind of where I'm going to stop for now. But those are some like big things that are done. But I will go and show you what the DBC looks like now. Oh, wowzers. There we go. Where are you? Refresh. RAM 3. Okay. So just because of how Cabana is written and made and all that stuff, it auto-generates the DBCs for us if we're just entering. I mean, I can put stuff in here manually if I want. I don't have to use Cabana. I can just write this. But Cabana is pretty cool because, you know, it gets all the pertinent information in there for us. So, for example, that lane keep assist state bit that I just, I guess, identified or whatever you want to call it, defined. Here's the information. Like it's the 25th bit. There's only one bit. It's either 0 or 1. And yeah, that's that. Down here, remember those comments I was putting in? I can see for CAN ID decimal 166, the LKAS state, you know, appears to be the ready indicator or whatever. So this is where the comments show up in the DBC. You can look for examples in other DBCs. For example, here's the DBC that's used on every currently sort of supported-ish Chrysler. Um, so yeah, steering rate, steer angle, which we found. I don't know where the rate is yet. I just haven't found it. Um, brake module, brake pressure. This speed one's an interesting one, but not required because we have all the individual wheel speeds defined already. Oh, here's wheel speeds. So yeah, when I'm looking for stuff in Cabana, I'm also referencing stuff that's already been done because this stuff, uh, the CAN IDs can be completely different, but some of this stuff is pretty similar. Like the lane keep commands coming from RAM are very similar, if not like identical to commands that are sent by other Chryslers already. One thing I did like about RAM was it's so good at holding like uh, steering angles. Like I really like that. So whenever you're trying to like tune your vehicle or tune Open Pilot for your vehicle, if you get to a place that has these horizontal flat lines, um, that means the steering wheel is not moving, which means it's not ping ponging. It's actually holding it. That's where you want to be eventually. Um, yeah, stock systems have like tons of engineers and tons of money and tons of time invested into them. So if we can get our open pilot commands turning the steering wheel like this, we're doing good. Uh, yeah, so I'm gonna stop. Um, I hope at least up and away. I hope it was helpful. I did record some of it, but I think Twitch hangs on to it for a little while, so I'll send a link to it. I'm not sure how long it keeps it for, but we'll see. I think that's it. Unless you have any questions. Anybody has any questions? All right, dudes, and all right, dudettes. If there's any girls that want to do self-driving cars watching, never will happen. Um, that's it for me, guys. Have a good night.